x raised to the power of 2x plus x raised to the power of x equals 20. Find x. Find x. Hi there, this is Daily Mathematics, and you are welcome to today's live stream. Today we want to have this question here, where we are to find x in this question, x raised to the power of 2x plus x raised to the power of x equals 20. Now, what's the first thing we're going to do if we have this question? So we know that when you have a raised to the power of m, right? When you have a raised to the power of m, right? Plus a raised to the power of m raised to the power of n, right? It can also become a raised to the power of n raised to the power of m, and so on and so forth. So from here, since you have x raised to the power of 2x plus x raised to the power of x, so this x raised to the power of 2x, right? Solution, x raised to the power of 2x can become x raised to the power of x raised to the power of 2, right? Plus x raised to the power of x equals 20, right? So from here, we can say let x raised to the power of x equals any letter of your choice, a, b, c, any letter of your choice. And so from here we have, from here, so since x raised to the power of x equals a, so from here we have a squared plus a equals 20, right? So from here, we bring this 20 to this side of the equation, we have a squared plus a minus 20 equals 0, right? So from here, what do you have? We have a quadratic equation, from here. So what do you do in a quadratic equation? You use your quadratic formula, right? You use your quadratic formula in the equation. So, but you can also use find two factors. If you don't want to go about your quadratic formula, you find two factors of this minus 20 that when it's added up, it can give you plus 1, because in this a there is 1 here. So when it's added up, it can give you plus 1, right? So what are the two factors we can find? So if we have factors of 20, we have 2 times, okay, 1 times 20, we have 2 times 10, we have 4 times 5. Right, if you can see this, 4 times 5 gives us 20, not minus 20. So you can see 4 times 5 gives us 20, not minus 20. And so, from here, if you put minus here, minus 4 times 5 gives us minus 20, and minus 4 plus 5 gives us plus 1. So we're good. So we can use this a squared, right, plus 5a minus 4a, because 5a minus 4a gives us 1a, and 5 times 4, 5 times minus 4 gives us minus 20, so we are good. Minus 20 equals 0. So from here, what is common in a squared and 5a? A is common. We have a plus 5, and here what's common? Minus 4 is common, so we can bring out minus 4, and when we bring out minus 4 from here, we have a plus 5, right, equals 0. So from here we have a plus 5 common, so we'll bring a plus 5 here, and when we bring out a plus 5 here, we have a here. When we bring out a plus 5 here, it has a minus 4 equals 0. So from here we have two things: a plus 5 equals 0, or a minus 4 equals 0, right? So from here we can see that a equals 0 minus 5, right? From here, 0 minus 5, so a equals minus 5. And from here, a equals 0 plus 4, a equals 4, right? So from here, we can see that we have minus 5 and 4. We have two values for the equation, but this minus 5 is not needed because it is a negative. It is a negative, right? So it's only this positive number that we're going to work out. And so we see that we said here, if you can look here, we said let x raised to the power of x equals a. So x raised to the power of x equals a, right? And so a, we find out that a is 4. So x raised to the power of x equals 4, right? Good. So from here, since x raised to the power of x equals 4, x raised to the power of x, what is 4? 4 is 2 raised to the power of 2, right? And so we have x raised to the power of itself equals 2 raised to the power of itself, and we can see this, that x is equals to 2. So how do we verify our answer? we are going to check it out, right? This is the question. The question says x raised to the power of 2x, plus x raised to the power of x equals 20. That's what the question says. And we found out that x here is 2, right? In this place, x is 2. So let's put 2 there. 2 raised to the power of 2x, x is 2, right? Plus 2 raised to the power of 2 equals 20. Does it give us 20? Right? So from here, 2 raised to the power of 2 times 2 gives us 4, right? Plus 2 raised to the power of 2 equals 20. Does it give us 20? So from here, 2 raised to the power of 4, that's 2 times 2 times 2 times 2. That's 2 in 4 places. If you check it, 2 in 4 places. That's 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So they have 16 plus 4. So 16 plus 4 gives us 20. So you can see 20 is equal to 20. So that means we are correct, right? So just for a bonus question, this is a question. Please don't forget to subscribe, like the video, like this live stream, right? Don't forget to subscribe to the channel. We have another interesting question here. If you can see this, an interesting question. 3 raised to the power of root x plus 3 raised to the power of root x equals 162. How do we go about this? Now, the first thing we want to do is that we have 3 raised to the power of root x and 3 raised to the power of root x here. What do we do? So, first thing we're going to do is to bring it out. It's common, right? So, we bring 3 raised to the power of root x. And when we bring it out from here, when we factorize it out, we have 1 plus 1 equals 162, right? And so, we have 3 raised to the power of root x times 1 plus 1 gives us 2 equals 162. So from here we can 3 raised to the power of root x equals 81. So from here you can do the logarithm of both sides. If you have this, you can do the logarithm of both sides, or to the power of 4. That's 81, 3 raised to the power of 4. So from here we can see the bases are the same. We can equate the powers. Root x equals 4, right? So the square root, right, of this root x, we can cancel it by squaring both sides. So this x now becomes 4 squared. What is 4 squared? The value of 4 squared becomes, thank you for joining us today. Thank you for joining us today on these two beautiful questions that you can see here. The first one is this question that we've solved, and the second one is this other question that we've solved. Please don't forget to subscribe, and we'll see you next time. Thank you very much.